saved or whether it is getting deleted in some reason, deleted for some reasons. So like, why is that maintenance also need to be there? That is one of the component of services. And other than that, product catalog. So where the product has been listed in various category, where you just imagine how much product Amazon has right now. So which is which is really huge for a lot of categories, like category wise, a lot of product which is also going to be needed to be listed. And then even in the payment category, even in the payment services, there are a lot of things. The first, it might be a checkout where people are really adding to the cart, and if they are really clicking a buy now, so they'll be moving into the checkout. And even sometimes it might be like requesting for the refund or what is it, replacement. If it is a refund, that is also related to payment. So likewise, whenever you're talking about e-commerce as an example, it has a lot of services, lot of sub-components which we really wanted to work on. What if you are creating an application, you have created Netflix or something, you are keep on saving all the information like username and password, so those things in a certain database. Suddenly, if you are doing a very good level marketing, and if you are really going to scale your business well, where you are going to get lot of number of users, what if that database got outreach, which is like a in the throughout the whole application, that is going to reach a bottleneck where it really requires some additional additional resources to save the huge amount of databases. That is what the scaling is. So scaling tool, or scaling a web application, or scaling a web related platform, that is where we really wanted to know about some scaling architecture. So while talking about the scaling architecture, there are two types. One is monolithic and another one is a microservice architecture. Okay, first of all, before going in detail about each and every point, I would like to tell it in a simplest way. Okay, so normally, traditionally, whenever people are creating an application, they will be doing it with the help of monolithic. What is meant by monolithic is, it is like having one box. In that box, it contains all the things inside a single box. If you are doing a Netflix clone or this Amazon website, the other components and services like this account section, or return on orders, and add to cart, and wish list, and checkout, and product catalog, and search boxes, so even because whenever you are really searching about whenever you are really analyzing the top searches, apart from the Google search, there is another very important search people are searching a lot is Amazon search. So that is where the search bar. So likewise, whenever you're talking about the whole platform, it is going to have a lot of individual components or services. Whenever you're talking about a monolithic, everything which is going to be inside a single part or single segment, that is called monolithic. Whenever you are really learning from learning a full stack web development from normally, like whenever you're really learning from the courses, most of the time they will be teaching you to build the application using monolithic architecture, because it is very simple, where you don't want to complex your like the difficulty level, which is also going to be very, very less in the monolithic. Because as I've already told you, while talking about the monolithic, everything which is going to be created in a single, for an example, all the components like this user authentication, shopping cart, product catalog, payment, or refund or return, or wish list, or the search. So likewise, these are all the components which I'm talking about, guys. I hope you really like this example. So if you're talking about this Amazon, all these components which is going to be present in a single unit, that is called monolithic architecture. Okay, if we wanted to deploy it or scale it, it is easy, because it is just a single unit, right? It is a single unit where you have used one stack, one specific stack. That's what the topic which I'm going to talk about right now. So where it has been built by using one platform or not one thing. If you want to scale it, or if you want to deploy it, that is going to be done for the single unit. So scaling, even scaling, not even scaling. Scaling means it is not that much good. But if you are talking about the deployment and updating or something, it is like a single unit. You need to do it for a single unit. While talking about the stack, if you're really going to create an application, even while talking about the Netflix clone which you have created, we guys have simply used this HTML, CSS, and JavaScript. Okay, or even if you are creating that video testimonial tool, that video testimonial tool is also being created by using a normal stack. Likewise, you can go with a mean stack or MERN stack or MERN stack or LAMP stack, anything, but the whole application is being created by using one single specific stack. Are you clear? Okay, so it might be a mean or MERN or MERN, but if you are really seeing all these components, since everything which is present in a single unit in monolithic architecture, you should be using a single stack. It's not mean that you can use a different stack for handling account section. You can use a different stack for handling the card section. You can't use other stacks for handling the return on orders. So monolithic is the place where every component which is present in a single unit. So if you are going to use a certain stack, that stack should be used for all the components which is present in the single unit called monolithic architecture. Okay. And while talking about the third very important point, no one problem in one component will affect the whole application. Of course, right? You just imagine, since because every unit which is present in a single, every components and every services which is present in a single unit, if there is any problem, like any problem in a single thing, which is because whenever you are creating an application in a monolithic architecture, where every component which is going to be dependent on one another. So since because every dependencies of each and every components or services, if there is any problem which is occurring in that unit, it is going to affect the rest of the components or rest of the services. Okay. And while talking about the challenges, I have prepared some points. I hope you really like it. The first thing is application is complex. Okay. While talking about application is complex, of course, because sometimes this kind of difficulty I'm talking about, but creating an application is going to be simple, guys. Okay. Because it is a single unit application. Let me call it application creation is going to be simple. Okay. Why? Because it is, where it is a single unit where you're going to use one specific stack. So to create an application, it's going to be very easy to create with the help of this monolithic architecture. And another very important thing, you just imagine, certainly, okay, since because in this Amazon, as we have already discussed, there are a lot of units like cart or wish list or user database or product catalog database. Likewise, it is going to have a lot of services. So since everything which is present in a single unit, what if suddenly customer database is started increasing? Okay, suddenly I'm talking about one specific component called customer database, which is keep on increasing. So since every element or every services which is present in a certain unit, if you want to scale that alone, it might be difficult. So on the time, you need to scale throughout the whole unit. That's what the very important disadvantage. Because we can scale the complete application. We can't scale only one part DB. Okay, because you have created one application using monolithic architecture. Out of it, if any certain component or certain services which it really requires some scaling, you can't do it individually because everything is having a dependencies and also everything which is present in a single unit. And if you want to scale it, might be somewhat difficult. So you need to scale the whole complete application, which will lead to higher cost. Of course, right? You just think about it. So if it has multiple units like this, if you want to scale it, definitely you need to spend the money for all the components and services which is all present in this unit, which you need to scale it. So it is going to really cost you. Okay, that is what the second important disadvantage. And third thing is difficulty in using different versions for each component. You just imagine, guys. Okay, you just imagine in this monolithic, you have different components and services like payment or payment catalog or shopping cart and etc. If you are going to use one stack, of course, we need only one stack. And now you are using a MERN stack. Out of that, for the backend, we'll be using a Express and Node.js. What if the certain component in this monolithic architecture, the unit, like payment really requires Node.js 1.0? And what if product catalog which requires Node.js 1.4 version. And you just imagine shopping cart is the one of the component which requires Node.js 1.6. What will happen? Is it really hard? Of course, right? Because whenever you're talking about that single unit kind of monolithic architecture, since everything can be built by using a one single stack, and if there is any problem or any individual components or services which is present in that unit, it might demand you to use different version. So that is very, very hard to maintain. So that is also a third important disadvantage. And fourth is, if any modification in which has been made in any component, which need to be checked individually and also whole complete test. You just imagine in this Amazon website, it has accounts page, orders page, checkout component and services, and wish list. Likewise, there are a lot of components. If an application which has been created by monolithic, you just imagine if you are going to do some modification only on the checkout. So even though you are doing only modification in the checkout, since there is a dependencies among all the component which is present in this monolithic architecture, it will demand you to do the complete test again. Individual test will be there, but other than that, you'll be doing a complete test of application to make sure that is that dependencies is causing any issues or not. So that is what the fourth point. And fifth one, which is like if there is any bug in a certain component, as I've already told you, since everything which is present in a single unit, if there is any problem in any specific services or component, which will bring down our whole application. So that is what the fifth point. And sixth point, which is if we want to deploy this application, entire app wanted to be built and deployed, but it is easy. You can ask me why you are dropped in a disadvantage, but you just imagine if the application is bigger, you need to build the whole application instead of building as individual components. Okay, that is what monolithic is all about. But even though Google kind of bigger company also using monolithic, but monolithic which has been morely suitable for that specific small scale of application or something. Okay, are you clear? So I'm repeating again. Whenever a web application or something, especially if you are really checking out the e-commerce website or e-commerce platform or Netflix kind of platform, so it will have a lot of different components and services like accounts and list and orders and cart and wish list and etc. and product catalog and etc. So whenever you're talking about every component which is going to be be there in a single unit, so where you will be using a specific stack to build it, okay, to create that. Okay, so because everything which is present in a single unit, every component which is going to have a dependencies. Okay, so that is what monolithic is. Whereas whenever you are talking about scaling your application, okay, if you want to scale your application or scale your company, that is where microservices architecture is going to be coming in. Okay, while talking about the microservices, you can see the difference. Here, all the unit which is present in a single box. Okay, that is what monolithic. But microservices is handling each and every services individually. Are you clear? Instead of putting in a single unit and handling as like a one, here microservices is like splitting each and everything as a multiple services. For an example, if you're talking about this microservices, the first thing, splitting the whole application into smaller independent services. So instead of creating like one complete website or platform for Amazon, so we will be splitting that application into a smaller independent services. Now you might ask a question, Sanjay, are we going to split it based on the technical difficulties or technical work? No. Because whenever you're talking about the splitting, you should split it based on the business functionality. Because you just imagine, as we have already told you, whenever you're talking about this monolithic architecture, because everything which is present in a single unit, if you want to scale a certain thing, if you want to scale only the database, or if you want to scale a certain thing, you really wanted to scale the whole complete application, which is going to cost you a lot of money. But whenever you're going for the microservices architecture, because you are splitting it, that splitting should not be based on technical. Instead, that should be based on the business. Okay, how much the cost can be reduced by splitting that feature individually, so that we can scale only that part alone individually. Okay, are you clear? Even while talking about an example, so it can be a products or customers or cart or wish list or checkout. So one service should do only one job. Okay, it is not like a grouping the checkout and the products and refund all together. No, here whenever you're talking about one service is like, if it is a checkout, so that is going to do only that specific job. So, and also it is going to be independent. Just carefully watch, it is all independent services. But whenever you're going for this monolithic, every services which is all present in a single unit, which is dependent on one another. But here, since because we are splitting like this based on the business, so it is going to be completely independent. And even after independent, each splitted services should be, of course, as I've already told you, it is going to be independent, so that if you wanted to deploy or scale it, it can be done individually. Are you clear? So on that, throughout the whole application, if there is something which you need to scale a lot, for an example, it might be a database to save the customer's information, because suddenly we have got more sales or something. If you have got on that way, if you want to scale the application, that can be done with the help of that can be done for the specific services. Okay, you don't want to scale the complete application so that you can reduce lot of cost, because you can increase or you can scale that certain specific component or that certain specific services. So that's how you can able to reduce your cost. And while talking about another point, it can be it can use different version in different services, of course. So what are all the advantages which is out there? This is going to be disadvantages out there. This is going to be advantages in this microservices architecture. Since every component and every services which is all independent, which is not present in a certain unit, which is all independent right now. So you can execute or you can use different versions. Okay, you can use payment. For payment, you can use Node.js 1.0, or you can use catalog, product catalog with Node.js 1.4, or you can use shopping cart by using a Node.js 1.6. So likewise, there is that kind of leverages. And another important leverages which is also out there, it can choose, each and every microservices which it can choose individual stacks on its own. This is amazing, guys. Okay, look at that. If this is a microservices, this each and every box is a one microservice. Okay, for an example, this is for payment, this is for cart, this is for wish list, this is for checkout, this is for returns, and this is for product catalog, this is for the categories. Likewise, every individual thing which is going to be a microservice, since everything is all independent, if you wanted to use MERN stack here, you can use here. Especially it is like you can use Node.js for the backend here. Here you can use Python with Flask here. So you can use Java here. Okay, you can for an example, you can use Python for the analysis. Okay, if you are talking about the Instagram analysis, because that is an analytics platform, right? So it is going to show you how much reach you have got and everything. So for that analytics, you can specifically use Python there. Okay, if it is just notification, for the notification, you can use the Node.js there. So likewise, based on that certain need, you can use different stacks for different microservices, because everything is independent. Okay, that's a very important thing. And now you will get another question, Sanjay, how the communications are happening between these microservices. So guys, actually there's communication which has been happening in three ways. But before going for the three ways, I would like to tell you what is mean by this communication. Just see, this is the Amazon, the whole complete web application. So in this application, it has this add to cart, account list, and language, returns and orders, shopping cart, payments, and product catalog. So likewise, it is going to have a lot of components and microservices or components and those things. So whenever you're talking about the communication, even though everything which is on built individually by using a microservices architecture, definitely one want to communicate another, right? So add to cart need to communicate with the checkout, because once the people have ordered their product to the cart, it want to communicate to the checkout so that people can click that and people can pay for it and people can able to order it. And even that also, there is a payment is also one of the another component needed to be added. So that's why whenever you're creating this kind of application, even though it is every components and services which has been created as a individual microservices, there is going to be communication between one and another. So while talking about those communication, there are three ways. One is by using API calls. So API calls, as we have already discussed, it is going to have every microservices or the component which is going to be connected with the API. So which is like a HTTP request. Okay, so HTTP request and response. So it is, since it is a HTTP request and those things, it is going to be synchronous communication. So why? Because while talking about the each service or component, which is all going to have its own API, so which is going to be helpful for accept or request from other services. While talking about the accept or requests from other services, you just imagine this is a checkout component and this is the payment component. So once the people have entered their information and they are going to click a checkout, so this checkout component or service which will communicate through the API to this payment. And once it acknowledged, okay, I have received the packet, once I have acknowledged, then it is going to give the response to it. So request, response, request, response, request, response. That's what the API, right? So that is the first way. And even, of course, while talking about this kind of communication, it is going to be synchronous. So one service sends request service to another and wait for the responses. Okay, are you clear? So if it is a checkout will send some data, which is like a request for a certain action. And once that payment got received it, and it will be responding back. It is like a sync, okay, sync between this two or three or multiple components, where it is going to be communicating with each other by using an API, application programming interface. So that is the one way where the communication can happen. And second way is a message broker. So message broker, I don't know whether we have studied or not. Message broker, you just imagine like a YouTube channel, guys. YouTube channel is a certain topic. You can see the Pantech.ai or What is Your Hub YouTube channel. So if that is a YouTube channel, whoever subscribing to that topic called Pantech.ai or What is Your Hub YouTube channel, they all going to they are all going to get the notification whenever one new video got posted. Are you clear? So if there is a one YouTube channel, which is a topic, you just imagine it is a topic. Whenever people are subscribed to the certain topic, whoever really subscribed to the topic, they are going to get a notification when anything happened in there. So same as like it is like a subscriber and publisher kind of thing, which it can be done with the help of this message broker. And since it is this kind of publish or subscribe option, point-to-point messaging services, it is going to be asynchronous. Okay, it is going to keep on sending a stack of complete data continuously by itself, and where that is going to receive it or that is going to give a response for it. That is what this message broker is all about. Okay, I hope you guys have got an idea. Here we guys have saw two things. Number one is API call, which is completely synchronous because it is going to send the data through an API and it is going to give a request and it is going to respond it back. So that is how it will work. There is a second way, which is asynchronous communication, because it is on publisher or subscriber mode, where the topic where the people will be used to be publishing to a certain topic, so that whatever the message which is being broadcasted in that topic, these people always they are going to receive the data so continuously. So that's why it has been called as asynchronous communication. Whereas while talking about the third thing, which is called as a service mesh. So service mesh is like with the existing components and those things. Additionally, one helper service mesh will be there to take care of this complete communication between one services versus another or one component versus another. So that is what the service mesh is all about. Guys, right now, I hope you all really clear, because now we guys are on the monolithic architecture and what it is all about and what are the challenges in the monolithic. Now we are really exploring the microservices, which has all the advantages over the disadvantages of monolithic. And while talking about the communication, how each and every component, because if it is in a single unit like monolithic, the communication is going to be easy. But whenever you're talking about the component which is all present as like an individual services separately as a microservices, separate microservices. So if they really want to communicate one versus another, like product to the checkout or wish list to the cart or cart to the checkout. So likewise, if there is wanted to be some communication need to be happen, that can be done in a 3 ways. Number one is through API calls. Number two is by having a message broker in between. And third thing, which is like a service mesh. Are you clear? Are you satisfied? So this is how the communication which is going to be happening between different microservices. And while talking about the challenges, of course, everything which is going to have some challenges, right? So while talking about these challenges, the first thing you just see, since this architecture is distributed, of course, right, you can see how the diagram really looks like. Every microservices, every services which is present in this microservices, which is all independent. Since everything is independent, since everything is distributed, there will be a lot of challenges. Out of that, the first thing, communication configuration between each services. Because when you are talking about the monolithic, since every services and component present in a single unit, where that communication can be easily done. But since here, you people might be used here Python with Flash to work on that specific microservices. Another person might use Java to work on the certain microservices for add to cart. So you just imagine now the communication. That is where here, this is one of the difficulty where the communication configuration between each and every services, which is also one of the very important challenges, and also difficult to find which microservices is active or down. Guys, you just think about it. Okay, just think for a few seconds and just decide. If you're talking about Amazon, it has a lot of components. Even people are really hovering like this or clicking like this. And this hero section, you know, whenever you're talking about this, you just think about real Amazon, real Netflix, or real Prime Video, Hotstar, anything. There is going to be a lot of microservices, right? And whenever you're talking about a lot of microservices, it might be around, you just imagine 1,000 microservices. It might be like 10,000 microservices for one application I'm talking about. Okay, for one single Amazon website, you just think about how much microservices will be there. It is going to be microservices for cart, shopping, wish list, and what to say, wish list and payment and return, replacement, or some other thing like search bar and product catalog and category. So likewise, it is going to have a lot of microservices. You just imagine how much kind of microservices they used to have the application like this. So whenever you are working on this kind of huge amount of microservices, you might face a difficulty to handle it well. Even the communication is also going to be difficult. And it is also difficult to identify which microservices is down because everything is independent. Are you clear? So in the microservices, that is a very important thing which I've told you. Even though you have 1,000 microservices, all the 1,000 microservices are independent, which might be built by using different stacks. So because it is difficult to handle, that is where tools such as like Kubernetes are coming in. How many of you people have heard about the Kubernetes? If you have heard about it, you just post heard Sanjay in your comment. So guys, are you all really feeling this full stack journey is completely different from others? Yes, it is different from others because instead of just teaching you the Netflix clone by using a MERN stack and or HTML, CSS and JavaScript, so here you are really learning something big, which people are not even aware about it. So that is where Kubernetes are coming in, which is going to be helpful for managing huge complex microservices easily. So even though you have 1,000 microservices, which you can able to manage it easily with the help of the tools such as like Kubernetes. Okay, and I hope you really got it. And I'll talk about this refer part later. And before that, while talking about managing programs for microservices, what is meant by programs? It might be a source code. Okay, I'm talking about. Okay, because if you are talking about the Netflix clone, we can do it in a single-handed. Okay, normal, basic Netflix creation. But if you wanted to create that kind of level, scalable level, real Netflix, you really need a huge team, of course, right? So that is where people really calling us like a DevOps, a development plus operation and all, which is going to be, they'll be using this kind of tools like Kubernetes and all. So whenever you're talking about that, the program might be, I might be working in the front end, I'm okay. But apart from the front end, I will be working on the certain services maybe. And for an example, I might be working on the add to cart. Some person might be working on some services, not one person, as a team. So me and my 20 friends, 20 colleagues, we are going to work together on a one service called add to cart. So which is having a multiple sub microservice. So whenever you're talking about the code, source code of it, that is where we are talking about it here. So here there are two types. One is mono repo and another one is a poly repo. Even by comparing the picture, you can see, and I hope you already know this logo. What is this logo is? It is a Git. So while talking about the mono repo, if there is a project, that all the project A, all the project B, project C, everything which is going to be managed in a single repository called one GitHub repository. But whenever you're talking about the poly repo, where especially on the microservices, where you will be having a multiple repository for multiple project which you have. And but really both are having pros and cons. And while talking about the mono repos pros, one GitHub repository is enough for all the project. Okay, even though you have multiple components or those things, one Git repository is enough to maintain the whole project as in a single shot. So that is the first pros. And second thing, managing code easy, of course, right? You just imagine if it is a single program, not like single program means single file. It is like single application or all the project which is in a single Git repository. If you want to do the commit changes in the code, or if you wanted to push that from the Git, or if you want to pull that from the Git or something, that is going to be easy, right? Because it is only one repository which has all the projects. So that's why it is going to be easy. But whenever you're talking about the third thing, code tracking and changes will be easy, of course, because while talking about the Git, it is a version control. It is one of the version control, right? So you just imagine if one person, if you're talking about Shan, so if she is changing something in the code, or if she is modifying one part of the code, that code need to be tracked. I hope you all remember the Git session. So that Git code tracking and also the changes which she or me or any other person who is doing in the code, everything can be tracked easily because it is one Git repository. It is not only Git, guys. You can consider any version control or any repository. But the code tracking and changes which we are doing in the code is going to be easy because it is a single repository. Okay, that is what the advantages of this monorepo. And while talking about the cons, first one, dependencies of each codes. You just imagine, since everything which is present in a single repository, as we have already discussed this point, that each code's dependencies might be different. So this code dependency might be different version, which it might be required. This might be requiring a different thing. So likewise, different dependencies of each code is going to be different. That is a point number one. And point number two, pushing or pulling huge repo. Guys, if it is a normal repository like the files which we have, it is very easy to push and then pull. It might be having around 100 files even though it is 100 files, that's easy. What if you are creating something big like Amazon or Netflix or working on it? It is going to have a lot of things. So you just imagine to push or pulling that kind of huge repository will be definitely time taking. So that's our second important point. And third, CI/CD. How many of you really remember the CI/CD, guys? CI/CD is continuous integration and continuous deployment, which is going to become limited. Why? Because while talking about the CI/CD pipelines and all, if you are really creating it with the help of any tools, that tools list I'm going to give it to you, don't worry. So whenever you're talking about the creating a CI/CD pipeline for the tool, since this mono repository is a single repository which contains all the project in a single repo, if you wanted to be deployed continuous integration and continuous deployment, which we have already did it with the help of Docker and Heroku and Git. So if you want to do that, here also it can be done, but it is not going to use like multiple processing and of thing and all, because it can create only one pipeline to execute the CI/CD, because it is a mono repository which has all the projects in a single repo. So that's what the disadvantages over there. While talking about the poly repo, these are all the advantages for this poly repo. So what are the disadvantages which you have saw in the mono repo, which is going to be advantage? The first thing is separate Git project for each services. For add to cart services, for wishlist services, for search services, everything it is going to have a separate Git project, Git repository for it. And second thing, codes are independent, of course, because here, even though you are modifying if you are doing any changes in this project A, it will affect the project, might affect the project B as well, because everything which has been in a single repo. But here, since every codes are completely independent, even if you are doing any modification, which is there if it is getting any bugs on the project A, it is not going to affect the second repository, because every repository which is all individual and independent. And while talking about the third point, CI/CD is easy. Of course. Why? Because here, if you wanted to do a CI/CD, it is a one pipeline which is going to use that CI/CD, continuous integration and continuous deployment, for the whole complete repository, which is a single pipeline. But here we don't want to do that. Why? Because we have individual repository. So one repository for project A, which is like add to cart, and one repository for shipping, one repository for wish list. Since because it has every different repository, so every repository which we can pass as a individual CI/CD. So everything which is going to be automatically deployed and integrated. That's a polyrepos advantages. And while talking about the disadvantages, the first cons is, since it has multiple repository for each services, managing might be difficult than monorepo, of course. Because here I have only one repository which it can easily run, which it can be able to be easily executed. But here in the polyrepo, since it has a lot of, repository, it is gonna be really, really difficult to manage. But I'm talking about, so even you have one repository for add to cart, one repository for shipping, one repository for wish list, one repository for search or something. Even though it is really difficult to manage it properly, you can use some of the features by the tools like GitLab. So GitLab is there. Okay, not a GitHub, it is a GitLab. So GitLab is having one of the feature called GitLab groups. So by using a groups, what you can do is, even though it is an individual repository for every individual services, you can group together as a single unit. So whatever the repo which is present in it for the individual services, which is all going to be independent, but is also going to be grouped as for the whole project for like Amazon or something. So which it can be easily be maintained. That's what the cons is. And con second is, since it has multiple repository, working in whole project might be difficult. Yes. So that's what the difficulty which I've already talked about. And that is where even we can use this type of, So this type of tools such as like Git lab groups and all. Okay, are you clear? So for this problem, since because it is having a huge repository and those things, we can able to solve this problem by using this kind of solutions like GitLab groups, so that that repo can be grouped together, so that you can able to work with on any modification and those things. Another very important disadvantage are code tracking, debugging, sharing will be difficult, of course, right? You just imagine if it is a single unit like this, like monorepo, it can be easily shared. Okay, it can be easily debugged, it can be tracked, it can be maintained easily. But here maintenance might be a little bit harder, because code tracking, debugging, sharing should be done for every individual repository. So that's what the very important thing, guys. Guys, are you all really got some advanced idea in a very simplest way? I really made this mind map to be very, very helpful for you. I hope you really love this mind maps and all. If you really love this mind map, If you really like this advanced content, you just post love this Sanjay in your comment. So now I'm going to bulkly reveal one thing which is going to be really looking good. Okay. So what are all the tools which you need to be aware about it whenever you are really wanted to scale your application? Guys, again, I'm telling you, still bigger companies are using monolithic architecture, but whenever it is needed to be scaled well, so people will be moving on to the microservices architecture. So that's what as a developer you need to know. And while talking about another important thing which all the developers should know is tools. So based on the need, it can be like for logging, it can be for monitoring, it can be for different category. So you really require some certain tool. So while talking about the category, containerization and orchestration. So while talking about the containerization and orchestration, we have already discussed about this containerization and all, where we guys have used the Docker to merge it off all the repository of our source code into us like a Docker image, and we can put that Docker image into the Docker Hub. So whenever people really want it, they can able to pull it from it, they can execute it. So first category is containerization and Docker orchestration. And second thing is monitoring and logging, like monitoring your the complete this microservices, and also logging it, because you need to get the log to see the output, what are all the error results we are getting or anything. It can be a log, it can be a positive or negative logs. So that is like monitoring and logging your application. So that is the third category. And fourth category is load balancing and caching. Because whenever you are really handling this type of huge number of microservices, you also need to balance your loads, which is really whether it is distributing it properly or not, and catching also you need to handle it. And fourth category is CI/CD, of course, continuous integration and continuous deployment tools. And fifth is serverless computing. Guys, sometimes serverless computing, if you are talking about it, it is so dumb, because serverless computing, it does not mean that without a server, it is going to be managed by another third-party member. Okay, apart from you, you are going to handle it by yourself. It is going to be managed by AWS, something like that. There is some tools, I'll reveal it. And while talking about the sixth one, event streaming or asynchronous messaging. So for that kind of category. And seventh is service discovery and configuration, if you really want to configure those kind of services, which is available for that purposes. And even secret management. Secret management is, of course, your login credentials and those things. So under this category, I've made a very good list of the tools which you need to be aware about it. So that's what I'm going to reveal. So once you have seen the tools, don't get scared about each and every tool, guys. Go and take your time and read it. Okay, just go through all the tools. Okay, while talking about the containerization and orchestration, the first thing, which is a Docker. So platform for developing or shipping or running application in the containers to ensure consistency across different environments. And while talking about the this orchestration, container orchestration platform for automating deployment, scaling, and operation for containerized application. So for containering, we will be doing it with the help of the Docker. And once it has been containerized, that containerized application, which is going to be automated for deployment and for scaling, we'll be using a Kubernetes. And Helm is also there, which is going to be helpful for the Kubernetes, which is like a Kubernetes package manager for deploying and managing application. So that is what this three tools for containerization and orchestration. So what is your going to be your task is, you're going to go and refer it, and you're going to build something, anything which is really possible in a small way. So go and refer this, what the Kubernetes is, what is the Helm will do, kind of thing. And while talking about the second category called monitoring and logging, here we have Prometheus. Prometheus is somewhat popular, where it is an open source monitoring and alerting toolkit designed for reliability and scalability, because it is having that monitoring and alerting. So if there is any problem with that architecture, the network which you have created, so it is going to be helpful for monitor it and alert you. So that is what Prometheus is there, and Grafana is there, and ELK stack. ELK is nothing but Elasticsearch and Logstash and Kibana. So set of tools for searching, analyzing, and visualizing a log data in a real time. And of course, there is a data log. So monitoring and observability platform for tracking application performance. Because if you wanted to see the performance, you need to see the log, right? You just imagine if you are running the application at January. So if you want to see the past performance in February, about the past performance on the January, so that can be done with the help of logging. So that's what the data log is all about. And while talking about the load balancing and caching, because you need to give your application need to give a high performance by having both on design aspects and functional aspects. So that is where we'll be using a tools such as like engines and hub proxy. Okay, so that's what the third tool. And fourth is CI/CD tools. While talking about the CI/CD tools, GitLab we have already saw. So GitLab CI/CD, or else you can use, we have used the GitHub as well. And while talking about the GitHub, yes, this is what we have done, like by using GitHub Actions. So we guys have automated a CI/CD. Even we have deployed it with the help of Heroku. I hope you all remember that. So by using a Heroku, we guys have deployed, the application, which is like continuous integration and continuous deployment. So whenever you are doing any modification in the code, which is going to be tested and which is going to be integrated with that and is going to be deployed in the Heroku, we guys have did it with the help of GitHub Actions. And also another tool which is out there, which is a Jenkins. So, and while talking about the serverless computing, as I've already told you, serverless is not like server is not there, server is zero kind of thing, which is going to be handled by that certain providers. Like if you're talking about AWS Lambda, they will be handling it. So serverless computer services that runs code in response to events without provisioning or managing servers. Okay, so that is going to be handled by this tool such as like AWS Lambda or Azure Functions. And for asynchronous messaging, we'll be using the tools such as like Apache Kafka, so which is distributed event streaming platform for highly handling throughout the data pipelines and real-time data processing, like the Netflix, which they'll be using it. So Netflix, they might be using it. So that kind of streaming platform, high streaming platform, the Kafka might be used. And service discovery and configuration. So if you really wanted to do the configuration management tool and doing a dynamic service registration. So because now we have only few services like add to card or something. What if based on the user interaction, if some new services which is needed to be added with the existing architecture, so that thing can be done with the help of Consul. And another very popular secret management platform is the Vault. Okay, secret management tool for securely storing and accessing sensitive data such as like API keys and passwords. So this Vault, which has been majorly used. And right now I've told you something here, right, in the refer category. So this is what you need to refer. So which is called as like HashiCorp. Okay. So what you guys do is you just open your browser and you just type HashiCorp, because this HashiCorp is a kind of like infrastructure. It is not kind of, it is like infrastructure cloud company, which is going to be really, really helpful for every category we have shown. So now we have shown the different category, right? So even while talking about this for containerization or monitoring and logging and load balancing, so likewise we have shown some category, right? So for those category, this is an infrastructure tool to maintain everything. So while talking about the products, you can see infrastructure. For infrastructure lifecycle management, there are tools like Terraform. Terraform is also popular. I hope you might have heard about it. So provisioning cloud infrastructure using a common workflow. Packer, build and manage images as a code. And Waypoint, internal developer platform. Nomad, workflow scheduling and orchestration. And security lifecycle management, which is like Vault, which we have found right now. And Consul, which is service-based networking, and Boundary. So likewise, it has a lot of things. Go and just read these docs, guys. Okay, in the infrastructure, we have Terraform for infrastructure provisioning, Packer for image management, Nomad for workload orchestration, and Waypoint for developer platform. Whereas if you're talking about the second category, one is infrastructure, another one is a security. So in the security, we'll be having a tools category such as like Vault or Boundary or Consul. Okay, so you just go through it. So HashiCorp, I'm just going for the Vault. So you can see secure application identities and protect sensitive data, manage access to secrets and stop credential from falling into the wrong hands with identity based security. So look out that, guys. Okay, so do you really love this? Yeah, this is what, go and read, go and take some time apart from our courses. Please go and spend your time on going through what all the tools is all about, how this Netflix are really using it, how the Amazon Prime Video, AWS are really using it, how this other things like Azure is using it, and how the OYO rooms, or how they are really managing their application, how they are really scaling it well. And even the chat GPT, you can consider now while talking about that platform where you will be entering your details and people, they'll be typing it. So which is like, you just think about how much big it is. Apart from this kind of DevOps skill, there a generative AI is also going to play its role. Okay, can you believe it? How much big the world is right now? How big the technology is right now? Because now we are really seeing only on the architecture level, like monolithic or microservices, and how all the data will be handled, and how the codes can be maintained in the bigger MNCs like Microsoft or Google or Netflix or something. But other than that, if you are really seeing as a whole complete product, like even if you are talking about the chat GPT, it should allow only the paid participants. Of course, yes, of course, it is a Amazon also in the same way, whether it is a Prime member or is it a normal member or even a chat GPT, what is the subscriber plan they have chosen? Is can they able to access the chat GPT 4.0 or something? So likewise, if you are talking about the real tool on the bigger level, it is way more bigger than anything. So that's why full stack is not just creating front end and back ends. Okay, you need to work on creating a front end. You need to work on creating a back end. You need to create. You need to work on databases. You need to work on APIs, and you need to work on writing the code effectively, so that you can able to optimize the performance of your web application or website. Performance in the sense it can be like a loading speed, or it can be like without any bugs, or it can be another important thing apart from the performance, which is like a security, where all the data which needed to be protected, it should not be leak any information outside of the web application. So security also a very important consideration you need to have. And after the security, we need to have a consideration on scaling an application, because if you are working in a certain project, even that video testimonial tool we are working on, right? If you are talking about that video testimonial tool, even though we have built it well right now, it is working good, but what if that Google API is not enough? Okay, definitely, if you just imagine in my live, in my some of the live which I'm conducting, I will have 5,000 people in my hand, in the live. So after they have listened to my teaching methodology, they will love it. And when I'm giving that video testimonial link to that 5,000 people, do you really think it will work perfectly? Out of 5,000, you just imagine 7,000 people, out of 5,000, 4,000 people are clicking that link. And if they have clicked the link, they are going to open it in their laptop or mobile phone. So whenever they are opening it in their mobile phone or laptop, it is like single within that certain 20 seconds, all people will be using, or all people will be opening our video testimonial tool. Once it got open, definitely it is not going to work well, because we are really reaching a bottleneck. Because some certain time, how much people can able to be there in the hosting, based on the hosting which we have chosen. So it is also going to reach a bottleneck. That is one of the disadvantages out there. Disadvantages on
Anjali, Anshika, Arshil, Asha, Bansi, Chandan, Chatamuni, Dayal, Jay, Joseph, Juhi, Krishna, Mansi, Mithun, Ashmir, Muskan, Neha, Nitin, Parminder, Payal, Prithviraj, Priyanshu, Rahul, Raju, Ramaya, Rohit, Sandesh, Sham, Sipten, Shovik, Shrikant, Uday, Valand, Vinay, Vishal, Brajesh, and all the people. If I was not able to take your name, I'm sorry for that. And are you guys excited? Type E in the comment section if you guys are excited. Everyone, right? So guys, this session will gonna be a great session, okay? And you guys will gonna learn crazy things in this, okay? Now, एक चीज मैं जो करने वाला हूं quickly with you, let me quickly share my screen with